All right, guys, we are on our last unit, and this one's going to seem kind of familiar because we are going to be covering the same types of things that we did when we did absolute value graphs. A lot of the things carry over, so if you did well with those, you're going to do well with these. So we are still dealing with these quadratics. You are going to need your calculator. I'm going to be using Desmos again to kind of show you how to plug these in. But I want to show you like what these graphs look like. So it's basically all about graphing. So if you don't like graphing, I'm sorry. I'm going to try to make this as painless as possible. Today's going to seem kind of long because we are kind of covering the like nuts and bolts of all of this. So this is a quadratic equation because it has an x squared. When you are completing a table of values, and honestly, you're not going to have to do it much. You will have to do it today to kind of see what the graphs look like. And I actually might get rid of some of those problems on your assignment now that I'm talking about it because they do take a little bit to make the tables. But when you are plugging these in, the main thing is that when you're plugging these values in for x, whenever you plug the x in, you have to put it in parentheses. So like when I want to plug this -2 to this -2 squared in, I have to do parenthesis, -2, parenthesis, squared. You have to put the parentheses. If you don't put the parentheses, it's going to tell you -4 because your calculator does order of operations. So when you plug in a -2, you get a +4. When I plug in a -1, I get a +1. When I plug in a 0, I get 0. When I plug in a 1, I get 1. And when I plug in a 4, when I plug in a 2, I get 4. I got ahead of myself there. So this f of x equals x squared is called your parent function. This is going to be kind of like when we did absolute values, we had our parent function, which always was at 0, 0, like the vertex. This is going to be like your parent function, or this is what you're going to go off of when we are doing translations or your characteristics or things like that. So let's graph this and take a look at what it looks like. So if we do -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. So they do look very similar, except these are V's that we did before, and these ones are U's. So when you are graphing these, you need to make sure that you make U's out of them. And then what we're going to be doing today is listing out the key characteristics. So this is why I'm going to get rid of some of them, because the key characteristics, there are 1, 2, 3, 4, 5, 6, 7 of them. 8 technically too. So for the key characteristics, and so this was our parent function. This is it again, just down here graphed. What you do, or what we're looking for, this is basically the order they're going to go in. We are always going to be looking for the domain, the range. You're going to be looking for the vertex. That actually may usually come first. And from the vertex is going to come your axis of symmetry because your graphs are symmetric, which means you can fold them in half. So 1, 2, 3, 4. Then what you're going to do is you're going to take a look at your graph and figure out the interval where your graph is increasing. So we're going to have an increasing interval. I promise this isn't too bad. Just stick with me. And then you're going to have a decreasing interval. And a lot of these things like are the same for every single problem. So that's kind of nice too. Increasing, decreasing. You're going to have to figure out if your vertex is a minimum or a maximum. And that's kind of just going to be a circle thing. And then you're also going to have to look at the shape of your graph and figure out, does your graph open up or open down? And I'm going to show you a way to kind of shortcut that and be able to figure it out without having to graph it. I'm going to show you how to do all of these without graphing. It's kind of nice. Or I guess just with sketching. You'll be able to do these with sketching. You're going to have to probably sketch them. So the domain, just like with absolute values and basically everything that we've done this whole entire year, the domain is how far left it goes, how far right it goes. We don't know how far left these graphs go. We don't know how far right they go. So the domain is always going to be -infinity to +infinity. That doesn't change. The range, how low does it go? This one goes down to 0. and it includes the 0. There's an actual point there. How high does it go? We don't know, so infinity. Vertex, that's going to be either the very lowest or the very highest point on your graph, or where your graph kind of changes directions. Your vertex is right here at 0, 0. The axis of symmetry is the x equals line where your graph cuts in half, and it's right here. And right here, your x value is 0. It's always going to be x equals the x value of your vertex. So these two things are new, and these are all based off of the x-axis. So where is your graph increasing? So it starts increasing right here, and it increases from here all the way. So right here, the x value, so these are all x's. You've got to remember that those are x values. So it starts increasing when x is 0, and it keeps increasing until we get to infinity. And then decreasing, it starts decreasing at, well, we don't know where it starts, so we're going to say negative infinity, and it decreases until we get to 0. This will be like kind of the weird thing. This is where you're going to need to graph it, or I guess you don't really need to graph it if you can kind of get the shape of it in your mind. Then you're going to figure out, is your vertex a min or a max? Is it a minimum or a maximum? Is it the lowest point or the highest point? Your vertex right here is a minimum because it is the very lowest point. And then does your graph open up or open down? Or you can think of it as, does it point up or does it point down? And if you were to draw the arrows in this case are pointing up. So I know this is a lot, bear with me, but you are going to have to come up with all of these. It's not too bad, as you can see, it kind of carries over from what we've done before. And these graphs, they have a special funky name called a parabola. So these are parabolas. The rest of the unit is all of these parabolas. So let me show you kind of what else you're going to be doing today. Another example. So right here, we're going to fill in this table, and then we're going to graph it and come up with the key characteristics. So we've already graphed the parent function. So this is that 0, 0, and then we're going to figure out how does just putting this 2 out in front change things. So when we plug this into Desmos, though, we're going to have to put 2 parenthesis x squared. So the only thing that gets put in the parentheses is whatever you are plugging in for x. So we're going to do 2 parentheses negative 2 and my parentheses squared, and I get an 8. And then instead of a negative 2, I plug in a negative 1, and I get a 2. Instead of negative 1, I plug in a 0, and I get 0. And instead of a 0, I want a 1. And instead of a 1, I want a 2. And as you can see, it's symmetric. They do repeat themselves. So let's graph this and see what this looks like. Negative 2, 8. Negative 1, 2. 0, 0. 1, 2. And then 2, 8. So this graph just got narrower. So that's going to be another thing that we talk about today is narrow and wide. So if your x, or if the number out in front is 2, it makes your graph a little bit narrower towards the y-axis. So now that we have this graphed, let's find the key characteristics. So the vertex is still 0, 0. Axis of symmetry is always going to be x equals the x value of your vertex. The domain for all of these, no matter what, never changes. I feel like we've always written it that way. The range is the only thing you're going to need to be careful on, just making sure you know what the graph looks like. So the range in this case, how low does it go? 0. How high does it go? We don't know. So 0 to we don't know. Do we have a minimum or a maximum? In this case, we have a minimum value. Interval where the graph increases. So the graph is going to increase from here on up, and right here the x value is 0, so it increases from 0 to infinity, and it decreases. We don't know where it starts to decrease, so if you don't know where that is, it's negative infinity, and it keeps decreasing until it gets to here 0. And this opens up if they were to ask that. All right, let's take a look at another one. I just want to show you one more of these graphs. All right, so number 3 here, in this one, when you plug into Desmos, you're going to put -2 parentheses x squared. Now, the difference now is that we do have a negative sign out in front of x, or in front of the negative, or the 2, I'm sorry. So when I plug in a -2, you get a -8. When you plug in a -1, you get a -2. When you plug in a 0, you get 0. When you plug in a 1, you get -2. And when you plug in a 2, you get -8. So now if we go to graph these, -2, -8 is going to be somewhere down there. -1, -2 is right there. 0, 0. 1, -2 is right there. And then 2, -8. And then this is what your graph looks like. So this one is a little different. So key characteristics on this one, vertex is still 0, 0. The axis of symmetry is going to be x equals the x value of your vertex right here. The domain is always going to be -infinity to +infinity. Now the range, how low does it go, comma, how high does it go? How low does it go? We don't know. How high does it go? 0. So these ones are, the range will be different. Does this one have a minimum or a maximum? Well, it has this point right here, which is the highest that your graph goes. So this one has a maximum. Interval where the graph increases. So it's increasing right here. So we don't know when it starts increasing. So that'd be -infinity. And then it increases until we get to 0. And then where is it decreasing? It starts here at 0. And it keeps decreasing forever. So that's the main different thing for for these graphs. The other thing I need to show you is something that I'm hoping that I can get through quick so that you guys hopefully I want to make this as easy as possible. So main thing to keep in mind today, we're not going to look at this stuff, is that if A is negative, so if that number out in front, so all of these equations are still going to be in standard form. Remember, standard form is y equals ax squared, and then there's stuff outside of here. If this number is negative, that means that your graph opens down. So if A is negative, your graph's going to look like this. If A is positive, then your graph's going to look like this. So this is if A is positive. The other thing that we're going to have to deal with today also is, what if that A is a 2, or what if that A is a 1/2? What does that do to the actual graph? So if A is less than 1, so if it's less than 1, not thinking about signs. So today, what we're about to do, you need to not think about them having like positive or negative signs. If A is less than 1, that means that your graph is going to get wider. If your A is greater than 1, that means that your graph is going to get narrower, meaning it's going to get really, really close to the y-axis. So the other thing you have to do today is take a look here and say, how does it affect it? Does it get wider or does it get narrower? So this one, your A is 3. 3 is bigger than 1, so that means that it was going to get narrower. For this one, your A is -1/4. Not thinking about the sign, 1/4 is 0.25. 0.25 is less than 1, so that means that this is going to get wider. 2/3 is 0.6 repeating. That means it's going to get wider. And then -2, take away the sign, 2 is greater than 1, so that means that this is going to be narrower. So that's the other thing you're going to do today. One more thing is, if you had to order the groups from widest to narrowest. Widest means that it's the smallest number. Narrowest means that it's the largest number without looking at signs. So if we take a look here, the smallest number, the smallest A without looking at signs, is 1/4. So this is going to be the first one that we write. So, and then the next biggest is going to be this one. And then the next biggest. And then the final one, this is the largest. So hopefully that helps a little bit. Reach out if you have any questions or rewind this if you need to.